Local maximum and local minimum. Let f be a function defined at x equals c. F of c is called a local maximum or a relative maximum if there exists some interval ab that contains c such that fx is less than or equal to f at c for all x in the interval ab, or we call the local maximum occurs at x equals c. F of c is called a local minimum or a relative minimum if there exists some interval ab that contains c such that fx is greater than or equal to fc for all x in the interval ab. And always say a local minimum occurs at x equals c. We also say the local extremum occurs at the point CFC, or the point CFC is a local extremum. So the local extremum, it could be local maximum or local minimum. Critical values, theorem of local extrema. If a function f is continuous on the interval AB and c is in the interval AB, and f at c is either a local maximum or a local minimum, then f prime at c equals 0 or f prime at c doesn't exist. Recall the f prime of x equals the slope of the tangent line. For the case that f prime at c equals 0, that means the slope of the tangent line at the point C is 0, or the horizontal slope, or horizontal tangent. For f prime at C doesn't exist. So in this case, it's going to be the case of m of the tangent, or the slope of the tangent is undefined. In this case, we have the vertical tangent. The first derivative test to determine the local extrema, which is either local max or local min for a non-constant function f continuous on the interval AB. We are considering the curve, not the line. Step number 1, find the critical values, which is the x value c in the interval AB such that f prime at c equals 0 or f prime at c is undefined to identify either the horizontal tangent or the vertical tangent at that point C. Step 2, we draw a real number line like what we did before to identify the increasing decreasing graph, and then mark all the critical x values on it. Check the sign of the f prime on each side of the x equals c if the sign changes. If the sign changing from positive to negative or from increasing graph to decreasing graph, then f of c is the local maximum value. For the sign changing from negative, which is decreasing, to positive, which is increasing, the f of c is a local minimum value. Step 3, if there is no sign change for the f prime from the left side to the right side of the x equals c, then fc is not a local extremum. In this example, f of x equals negative 1 over 3 x to the third plus x to the second plus 3x plus 1. Part A, find the critical values of the function f, and part B, use the first derivative test to find any local extrema, and part C, suggest the graph of the f. First of all, find the critical value of the f, or identify the c for f prime at c equals 0, or f prime at c is undefined. The f prime for this function is negative 1/3 times 3, which is negative 1, x to the second, plus 2x plus 3. And find the critical value c. This is a polynomial function there is no restriction. So the case of the undefined is not considered. We're going to consider where f prime of the x equals 0. Factor completely, negative sign out, so negative x squared minus 2x minus 3 equals 0. We have the factor x minus 3 multiplied by x plus 1 multiplied by negative sign out front. This tells us the c or the critical number is 3 and c equals negative 1 as the critical values. And then part B, we're going to use the first derivative test to find any local extrema. Let's draw the real number line. Put the value of c on the line, which is negative 1 and positive 3. For the f prime of x equals negative of x minus 3 times x plus 1. Pick the value on the right side of the value 3. For example, if we pick the number 4, we have negative, if x equals 4, we get negative 4 minus 3 times 4 plus 1. The overall sign of the f prime gonna be negative inside. Similar for the middle interval, if we pick the value x equals 0, the f prime at 0 gonna be negative sign times positive sign. So we return positive sign for the sign of the f prime. And similar case, the left-hand side, we're gonna have the negative for the f prime. Okay. For the graph, the summary of the sign analysis, there will be negative sign on the right, positive sign in the middle, negative sign on the left. That means the graph is decreasing from negative infinity to negative 1. From negative 1 to positive 3, the graph is increasing. From 3 to infinity, the graph is decreasing. For the first derivative test, if the sign changing on the left from negative to positive, from decreasing to increasing, so x equals negative 1 gonna give you the local minimum value. Next, for the sign changing from positive side to the negative side, at the point x equals c equals 3, the graph is increasing and then decreasing. So the point x equals c gonna give you the local maximum value. And next, we're gonna use information to plot the graph. For both of the critical values, there is a sign change from one side of the value to another for the other. Therefore, the local extrema occurs at both x equals 0, x equals negative 1 and x equals 3. At x equals negative 1, we compute the function value to get negative 2 over 3, which is the local minimum point, and negative 2 over 3 is a local minimum value as a y value. Another critical point at x equals 3, find the function value to obtain 10. And this order pair 3, 10 is a local maximum point where the value 10 is a local maximum value. And put together in a graph. The local minimum at negative 1, negative 2/3, local maximum at 3, 10, and the graph decreasing on the left side of negative 1, increasing between negative 1 and 3, decreasing on the right side of 3.